This is Mr. Anderson for Kellogg Community College, going to talk about Chapter 2, Section 1, or the third session of our trigonometry class. The first thing we're going to do is quickly go over a common vocabulary for looking at angles, because we're going to be drawing some angles and doing some approximations of these. When you draw an angle, an angle is comprised of two rays, which are half lines, that attach at a vertex. The initial side is where you will start to draw your angle, and the terminal side is where it ends. Now there are three ways to get from the initial to the terminal side. One way is to go the shortest way counterclockwise, and this would be considered a positive rotation. If you go negative degrees or radians, you will go around clockwise, which takes you to the same measurement there, but through a much larger travel. And the third way is you can actually go beyond the rotation of a circle, so you can actually rotate more than 360 degrees to get to that side if you wish. Obviously there are an infinite number of multiples that you could go around the circle, either clockwise or counterclockwise, and land at that terminal angle, but generally we choose the most direct route counterclockwise. So in problem number 1, we will approximate an angle, a 60-degree angle from the initial side of 0 degrees. We'll take it to close to 90, as we did this on our special triangles. We did 30, 60, we did 30, 45, 60 degrees, then 90. So this is an approximate of 60 degrees right there from the initial to the terminal side. Now we're going to go negative 120 degrees, and I'm going to draw, instead of just the first quadrant like I did here, I'm going to draw the 4-quadrant system, and we would start at the initial side right here, and we would go 90 degrees, and then 90 degrees a little bit past that would be your 30 degrees beyond your 90. So this would be an example of a negative 120 degrees from the initial side of 0. The next piece is to go the third example is to go 540 degrees, which is more than one rotation of a circle. So if I subtract 360 degrees from 540, I'm left with an answer of 180. So it's one full revolution, then 180 degrees. So to show this on a 4-quadrant system, I would go around 360 degrees, and then I would continue to go 180, because that was what was left over when I subtracted my 540 degrees. So this is a 540 degree angle, though it is the same as a 180 degree angle. Now 4 pi 3 has us remind us a little bit about what a unit circle is, and one of the easiest things to think about when you think about a unit circle is 2 pi is a full rotation, but 1 pi is 180 degrees. So if we looked at it this way, this 4 pi thirds could be 3 pi thirds plus just 1 pi third. And we learned before that this 4 pi thirds is actually part of our unit circle, but if we wanted to remember in terms of degrees, this is 180 degrees here, because it's pi is 180 degrees, and pi over 3 is 60 degrees. So if we travel 180 degrees for the 3 pi thirds, yeah, and then we travel another pi over 3, so that'd be another 60 degrees, that would take us to this spot, which is 180 plus 60 degrees, or 240 degrees. So this is our 4 pi over 3 radian angle here. Now we're going to move to problem 5, and problem 5 is kind of neat because we're going to move a negative 2/3 pi here, and one of the marks on your special unit circle that we did back in session 1 here is that you saw that the 2 pi over 3 was this mark right here, which is 30 degrees past the 90 degree mark or the 120 degree mark. So if instead of us going positive 120 degrees, because this is equivalent to negative 120 degrees, we're going to rotate in this direction, negative 120. Or to think of it this way, pi over 3 was 60, so this would be 260 degrees in the negative rotation, so negative 120. You'll notice this is the same angle as problem number 4. So this is a negative 2 pi thirds, which is the same thing as the 240 degree rotation. Alright, so we're finally on to problem number 6. Problem number 6, an interesting way to look at this is to see this is definitely more than one revolution. So this is 20 pi over 4 plus 1 pi over 4. So this 20 pi plus 1 pi is 21 pi, but let's see how far around the circle are you going with 20 pi over 4. Well, that breaks down to 5 pi, and 5 pi is 5 180 spins around the unit circle, plus pi over 4, which is a 45 degree spin according to our unit circle. So again, let's go 5 180 degree spins, so 1, 2, 3, 4, 5, and then we're going to go a 45 degree spin, so there, my friends, is our answer for 21 pi over 4, which was 225 degrees from our initial to our terminal spot right there, not going around the circle anymore. Alright, so we did a little bit of approximations of graphing there. Let's do some conversions. Now on this page right here, we're going to convert to a decimal in degrees, and then we're going to convert from the degree minute seconds into a decimal, which is kind of neat. We're going to take this right here, which is 61 degrees, 42 minutes, 21 seconds. This is a measurement that goes much more into detail than degrees, and we're going to turn this into a decimal. Now to do that, it's kind of a clever process because we're going to take 61 minutes, whoops, do I have my pen on here? 61 degrees, and then 42 minutes, and then 21 seconds. Now to convert minutes into degrees, we can say that a minute is 1 degree, or sorry, 60 minutes make up 1 degree, so 42 multiplied by 1 over 60 gives us our answer to convert this into a decimal. Then if we looked at, since a minute is 1 out of 60, seconds would be a 60th of the 60th. So to turn 21 seconds into what I need to do here, I will go 1/60th times 1/60th. If I do all this correctly and type this in accurately, I now have 61 degrees. Since there are 60 minutes in a degree, this is going to convert that. And since there are 60 seconds in a minute, this will convert all this up to degrees, which will give us a decimal in degrees of 61.71 degrees. Now again, you'd have to type this in, but what you could do though is actually type this in and then store this in your calculator, and by hitting second enter, this would pop up again, so you'd be able to complete this a little faster with 73 degrees, 40 minutes multiplied by 1 over 60, plus 40 seconds multiplied by 1 over 60 quantity squared. And then this would give us the answer of 73.68 degrees. Finally here, we can again hit second enter to bring all this back up here. We're going to have 98 degrees, 22 minutes, 60 minutes in a degree, and then we have 45 seconds. And type all this in, get an approximation of 98.38 degrees. Now, to go backwards here, from a decimal, a degree decimal, to go backwards, we are going to use this principle of every smaller piece being 60 times less than that. So let's look at this. We're going to take our 61.24 degrees and break this up into 61 degrees plus 24 hundredths of a degree. Now we're going to take that 61 and multiply the 0.24, or the 24 hundredths, by 60. Now in doing that, the whole number is going to be our minutes. So multiplying 24 by 60 gives us an answer of 14.4. So this means we're going to have 61 degrees, 14 minutes, and then we have 0.4 minutes, which I can convert into seconds by multiplying this by 60. So you see how this is multiplied by 60, and this decimal will be technically multiplied by 60 twice. Well, multiplying that by 60, we have 61 degrees plus 14 minutes. 0.4 times 60 is going to be 24, or 24 seconds. Now, I don't need all of these pluses in the answer here. I just have to write 61 degrees, 14 minutes, 24 seconds. I can drop those little plus signs there. All right, I'm going to do one more problem, then move this up for problem 12. So this is going to be 29 degrees plus 411 thousandth of a degree. Now to convert this into minutes, I would multiply this by 60. And that would give me an answer of 24.66 minutes. So 29 degrees plus 24 minutes plus 0.66 hundredths of a minute, I would then multiply this by 60. And multiplying that by 60, I get an answer of 39.6 seconds. Now it says round your answer to the nearest second. So my answer is going to be 29 degrees, 24 minutes, and 40 seconds. Seconds denoted by the two tick marks there. All right, moving on to problem 12. I will need a little bit more room for this one here because it has kind of a weird middle part. This one here is going to start off with 44 degrees plus a hundredth of a, 1/100th. Now I'm going to turn this into see what happens when I multiply by 60, and what that gives me, it gives me 0.6 minutes. Now it's interesting that I now have 44 minutes plus 0.6 minutes, but that's not a whole number. So there's actually not going to be any minutes in this, it's just going to be degrees and seconds. If I multiply this by 60 again, what this gives me is 36, so I get 44 minutes plus 36 seconds. Notice there are 44 degrees, no minutes, 36 seconds. So when I write my answer, I've got to write it 44 degrees, 0 minutes, 36 seconds. A lot of us forget that we have to put that in there, so that's a common mistake on the first part of this section here. Now, if we're moving to the next piece here, which is converting each angle to radians, express your answer as a multiple of r. This is so much faster when you actually have memorized your unit circle. But what I'm going to do here is use the algorithm to do it instead. 1 degree of the unit circle is part of 360 degrees. Now, in terms of radians, a radian is defined by pi, because a pi is 180 degrees. So pi over 180, or 180 slivers on that first and second quadrant of the unit circle equals 1 degree. That kind of makes sense, because you consider that the unit circle, this is 180 degrees, this defines pi, so splitting that up into 180 pieces would be 180 degrees. So to convert 120 degrees into radians, I'd multiply by pi over 180. Now if I divide the top and bottom by 60, this becomes a 2 and this becomes a 3. So this is 2 pi thirds is the same as 120 degrees. If you know your unit circle, you don't have to go through these calculations. So here we have pi over 180. Divide the top and bottoms to reduce the fraction by 30 apiece. This would give me 11 pi over 6. Pi over 180, dividing the top and bottom by 30. This gives me a negative pi over 6. Multiplying by pi over 180 again, dividing top and bottom by the biggest number that can divide those, in this case is 90, that is going to give me 3 pi over 2. Which again, if you know your unit circle, that every 90 degree mark is going to be pi over 2, so this is 3 pi over 2. The negatives, you probably don't know your unit circle by negative degrees, which is, understandable, but you can subtract from 180 to find them. But since we're practicing the formula here, here's division of 20, or we can divide the top and bottom by 45, which means I'm going to have negative 5 fourths. and 180 degrees. You really shouldn't have to do the formula, but in case you do, 180 divided by itself is 1, so this would be negative pi, because going around negative 180 degrees is negative pi. Alright, so let's move to converting from angle to each angle to radians in degrees. Alright, now to do this, you're going to, we learned in the previous set of problems here, in the previous set of problems that 1 degree is equal to pi over 180 radians. So the formula for this one is kind of a nice cross multiplication equivalent, because if you want to figure out what is 1 radian, you would just crisscross your multiplication, and this would be 180 divided by pi. So 180 divided by pi degrees is equal to 1 radian. So what we'll do here is take each of these problems and multiply it by 180 over pi. And to do these problems, the pi's would simplify to 1. 5 times 180 divided by 6. This is definitely fast on the calculator, 150 degrees. This is going to be multiplied again by 180 over pi. Pi's divide out. 2 times 180 divided by 3, don't forget the negative, is 120 degrees. 4 pi, and this should be pretty simple and straightforward if you think about it for a moment. A 2 pi, and again, whoops, I wrote that on top. You draw out you divide the pi's by each other because that makes 1. 4 times 180 is 720 degrees. Now, another way to think of it is 2 pi is 360, so double that would be 720. So now I've got 180 divided by pi. Divide the pi's. So what I'm going to do is multiply 5 times 180 divided by 12. This gives me an answer of 75 degrees. Negative pi. We've had a problem like this earlier. Negative pi divided by pi is going to be negative 180, because that is the complement of problem 18 from up above here. And then what we're going to do for 24 is we're going to multiply the top and bottom here by 180 over pi. The pi simplify, so 3 times 180 divided by 4. 3 times 180 divided by 4, don't forget the negative, is 135 degrees. All right, that's great. This takes us through the first half of session 3. Thank you for watching.